Hello and welcome to Mathematical Coaching Center, and today we are going to discuss a theorem relating to the internal and the external angle of a triangle. The internal and the external angle of a triangle. But before we start, my name is Umang Khawas, and if you have any problem on learning mathematics, then consider subscribing to this channel. So let's see the statement of the theorem. The statement says that the external angle of a triangle is equal to the sum of the opposite internal angle. Okay, so there are two angles here, the external, the other one is the internal. So let's see what those two angles really mean. So let's first see the internal angle. The angle that is made inside these three angles here is known as the internal angle of a triangle. So these are the internal angle of a triangle. So let's see the external angle. So whenever you extend any one of the sides of a triangle, the angle that is formed in the outer part is known as the external angle. So this is the external angle here. So do we only get external angle here? No, we can extend any one of the sides. So let's extend this side here. So we are extending this side here. Okay, so not only this, you can also extend this line also. This line also can be extended, so we can extend this line here. So the angle that we get in the outer part, this angle, and here also we can get this angle here. So these are the external angle of a triangle. So these are the external angle of a triangle. Okay, now let's move back to the statement once again. So the statement says that the external angle, okay, so the external angle should be equal to the sum, the external angle should be equal to the sum of the opposite internal angle. So it should be equal to the opposite internal angle. So let's see. So here this angle is known as the external angle. In this diagram, this angle is the external angle. And what is the opposite internal angle? So this two angles formed here are the opposite internal angle. Okay, so these are the opposite angle. These are the opposite internal angle. So one more angle, internal angle is here. So this is the adjacent angle. Okay, this is the adjacent angle to this external angle. So this is not included here. Only these two angles are the opposite internal angle. So let's move on to the given part of a triangle. So in this we see that ABC is a triangle and BC is extended to the point D. So it is extended to the point D. So this is a triangle, this figure is a triangle, and this side BC is extended to the point till D. This is extended to the point till D. So what is the thing required to prove? That the external angle ECD, the external angle ECD should be equal to the sum of the two internal angle. It should be the sum. It should be sum. Whenever we add that two, we get the external angle. So angle BAC is this angle here. And what is ABC? What is ABC? ABC is this angle here. Okay, so when we add this two, angle BAC and angle ABC, what we get is we get angle ACD. We get angle ACD. So before we move on to proof, we need to construct something. Okay, let's see the construction. So in construction we need to construct a line. Okay, draw a line parallel to AB from the point C to the point till E. So we must make a line that is parallel to this AB, and it should start from the point C. It should start from the point C and it should end till some new point E. Okay, so let's see the construction. So this is the line here. So this is the line here, which is this line which is parallel to AB and which is from the point C and which goes to the point E. So this is the construction that we have done. Okay, so let's begin with the proof. In proof, we know that the side AB and C are parallel. How? Because of construction. We are constructing this we have constructed this line parallel to AB, so they must be parallel. Okay, so these two lines are parallel. So if the two lines are parallel, what happens is that AB will be equal to ECT. So AB, that is ABC, will be equal to ECD. These two angles will be equal. And why are these two angles equal? Because they are corresponding angle. These are corresponding angles. So this two angles will be equal because they are corresponding angles. Next on, we also get that BC will be equal to ACE. So BAC is this angle and ACE is this angle. So now why are these two angles equal? It's because they are alternate angle. Okay, so for you to understand it in an easy way, I have colored it in different colors. So these two angles are equal. Because why are these two angles equal? Because they are corresponding angles, and this angle and here this angle is equal. Why? Because they are alternate angle. Okay, so angle ABC is equals to angle ECD, and angle BAC is equals to angle ACE. So now angle ACD. So where is angle ACD? ACD is this angle here. So this is angle ACD. We can see from this diagram itself that this whole angle is nothing but it is the sum of angle ACE and ECD. So that is what we are going to write, that the whole angle ACE is equal to ECD. So angle ECD is equals to angle ACE and ECD. But again we know that this angle ACE is equals to BAC. AC is equals to BAC and ECD is equal to ABC. So what we'll do is we'll replace ACE by BAC and we'll replace ECD by ABC. So in the next line we are right, in place of AC we are writing ABC because these two are equal, and in place of ECD we are writing ABC because these two are equal. So finally what we get is that, what is ACD? ACD is nothing but it is the sum of BAC and ABC. So this was the thing that was required to prove C. Angle ACD is equals to BAC and ABC. So what is angle ACD? ACD is this angle here. What is BAC? BAC is this angle. And what is angle ABC? Angle ABC is this angle. So this completes the proof that the external angle, that is angle ACD, is equal to the sum of the opposite internal angle. So these two are opposite internal angle. So when we add these two opposite internal angles, what we get is the external angle. Okay, so this was quite an easy theorem, and hope you understood the proof of this theorem. So thank you for watching.